Let's get vertical and horizontal asymptotes of a rational function. When we were discussing finding domain of functions, we encountered rational functions and functions composed of dividing two functions, such as what we saw in example 1 and example 2 above. We know that when we have a fractional function, such as, for example, x plus 1 over x minus 7, the denominator cannot be 0, right? So what we know for sure, for using this example, this cannot be a 0, this whole denominator. Output cannot be equal to 0. So for example, what is the domain of this one, g of x? And we recognize that x cubed, again, if we make it equal to 0, figure out what it cannot be, we'll take the cube root of both sides. I mean, we can actually see what it is, but going through the process, and that gives us 0. So the domain of this function is negative infinity to infinity. Sorry, not true, not true. Negative infinity to 0. And then it picks up on the other side of 0, u, 0 to infinity. So that is domain, and basically, again, we can't have this. X cannot, the domain cannot have 0 as the input for this function. Okay, so what occurs at the undefined values? What values that make the denominator 0? That is the location of a vertical asymptote. Okay, a vertical asymptote is represented by a vertical line or in the form of x equals k. So for example, if I asked, what is a vertical asymptote here? So vertical asymptote of gx is x equaling and then 0. So I'm not saying make x equal, I'm now talking about a vertical line. That's not a single number, that is a line. So what does occur is all of a sudden we have right at 0. So columns x, just make this simple, y, got 1, -1, and 0 being here. There is a vertical line right here. I'm going to dash it because since this is a vertical asymptote, we usually dash these things. Okay, so it's a boundary. So it's a boundary where this function cannot cross. So again, when we look at the domain, it goes from negative infinity to 0. It stops dead goal here, and then 0 to infinity, and it cannot cross this vertical asymptote. Okay. Again, now where x equals k, where k is the value that makes the denominator equal to 0. But again, this is a single number. This is a line. So notice we don't wish we had different notation to distinguish, but we don't. It's the same notation. But the reader's got to know that this is a line, a vertical line. Well, this written here is a single value. It's not a line. So by context, we kind of understand how each one of these should be read. Linear equation, single value. Recall for polynomials, we introduced the power functions, where n is an integer to help us graph polynomial functions. We're going to do we're going to do so with rational functions, introducing two basic functions. So what are these two basic functions? So I'm going to graph one here. One is 1 over x. And you saw these, I think, before when we introduced basic functions. This is one of them. Now, what does this look like? Well, for example, if I enter 1 here, I get 1, I get 1. What if I enter -1 here? I got 1 divided by -1 is -1. So a -1, I get -1. Okay. And I can continue inputting, but I'm going to give you the basic look. As as x gets closer to 0, this number is getting smaller and smaller and smaller. So as we go towards 0, number below 1, this is getting smaller. For example, if I entered x equals 1/10, what is the output of this? Well, 1 over 1/10 is 10. So at 1/10, we're at 10. It's out of the picture here. 1 over 100, we're close, it's 100. So again, we're completely out of the picture, but it looks something like this. And then when I get beyond 1, if I enter 2, for example, at 2, I get 1/2. At 3, I get 1/3. And so on. So this gets closer and closer right here. And you'll notice there's a vertical asymptote at x equals 0. So right here, there's a vertical asymptote. They can't cross. And you notice as I make x bigger and bigger and bigger, the output will get closer to 0. And so there's a horizontal asymptote right here. Now, fun fact, you can cross a horizontal asymptote. You cannot cross a vertical asymptote. However, this graph will not cross this horizontal asymptote. And if I were to enter here negative values, the picture, you can try it yourself. You see that if I go closer to 0 from this end, I'll go a bigger negative number. And if I go in this direction, I'll hug this line too. So that's what 1 over x looks like. So remember, memorize. So memorize what this looks like. And again, what is the domain of this thing? Well, when I look at this, the domain is going to be, so domain is going to be negative infinity to 0, union 0 to infinity. Okay? So this one's the first one to memorize. What's the second one? I'm going to call this g of x to name it something different, but 1 over x squared. So what does this look like? I could start entering numbers here, but let's just enter a couple in our head. If I enter a 1 into this, 1 squared is 1, 1 divided by 1 is 1. So again, notice both of these are hitting here. If I enter negative 1 here, negative 1 squared is 1, 1 divided by 1 is 1, so negative 1 gives me 1 right here. And same thing, as I start to go above 1, notice the denominator is getting bigger, but much faster. For example, if I entered a 2 here, a 2 before gave me a half. A 2 here, 2 squared, gives me a quarter. So it's now going faster. It's towards 0. If I move in this direction towards 0, I would get the same picture as above, but it's just happening. Everything's happening faster here. So that's basically what it looks like. What if I go on the other side? It would look the same. It would look like this. So again, notice we have another vertical asymptote right at 0, x equals 0, just like before, and a horizontal asymptote right here as well at y equals 0. So again, I'm going to call this vertical asymptote for both of these is x equals 0, and then horizontal asymptote for both of these is y equals 0. So remember, a horizontal line is y equals something. In this case, a constant of some sort, but at 0, that's what it is. That's the line. So this is equation of a line. That's an equation of a line. Okay, so this one does make a little more sense because this is one with a slope of 0, and so then this is just the y-intercept. This one does not make a lot of sense concerning the equation of a line, but that's by definition. That's how we'll define a vertical line. So you have these two basic looks. And remember that if we were to negate, for example, let's say I decided to negate this g of x, then all of a sudden, what I would have is the same picture here, except that it's Upside down, again, just a transformation. That's all that's happening. So it will look like the same thing, but upside down. Similarly, if I were to negate f of x, what do I have? Well, now this point, which was right here, is now below, because that's a y output, and this point, which was up here, goes right down there, and then the graph just replicates, but it's flipped across the x-axis, just like the other one. So I'm not doing a very good job, but you get the idea. Okay. All right, and so these are the basic looks. So again, memorize all of them. Now, here's something else to memorize. Just like before, notice this is to the first power, this is to the second power. So if I have now this function h of x equal 1 over x to the n is even, for example, just like this is, then the picture is still going to look like this. Except, again, now that could be fourth power, sixth power, just like before, this thing is just going to get more and more exaggerated. It will always go through 1, -1 here. So go through 1, 1 and -1, 1. It will always do that, unless I negate or do something else. And if, see, now I do the following, give x is 1 over x to the n is odd, then it will always be this picture right here. But again, everything was happening much faster. If n is odd, then we're approaching 0 much faster, and then we're also climbing much faster right here. But it will still go through 1, -1, -1, -1. So again, also remember this fact is if n is odd, you'll get this picture. If n is even, you'll get that picture. The domain, notice for all of them, is -infinity to 0, 0 to infinity. And the vertical asymptotes and the horizontal asymptotes are the same for both, no matter what power we have. But these are the two basic looks, regardless of the power, really.